we're going to talk about how to find areas of compound shapes. If you look at all these shapes, they're not just one shape, they're multiple shapes either added or subtracted from each other. So this first one, what you hopefully see here is a triangle and a semicircle. Triangle, semicircle. Then when you look at that, okay, how do I find the area of this triangle? Well, not all the sides are given, because really all they have here is 2, which would mean that's 2 and so is that, because that is a radius and so is this. So the base is 4, height is 3. Base times height divided by 2, so that's 6 inches squared. And then for a semicircle, well, a circle is pi r squared right there, but you divide by 2 because you want half of it. And then you just take those two, add them together, and that right there is your area of that shape. So this one right here, hopefully you see a rectangle, but you're cutting out a triangle. So the rectangle right here is just 4 and 10, 40. The triangle here, well, you have to know if that's 4, so is this. And if that's 5, that's 5. So for this triangle, it's just base times height divided by 2. And then you subtract the 2. 40 minus 10, 30. For this one, hopefully you can see it as 2 rectangles. Or you can think of it as a big rectangle minus a small corner. But really, what I'm going to do is take the small plus the large. And for this one, how to get 3 right there? Well, if this is 9 and this is 6, that has to be 3. So that little triangle is 3 times 8, 24. This one right here is 6, but how to get 14? Well, it's 6 and 8 make 14. So that rectangle is 6 by 14, which is 84. Add those together, 108 cubic centimeters. Now this one, hopefully you see a semicircle and a rectangle, rectangle, semicircle. The semicircle here, the radius is 11, so pi r squared, half. Right here, it's just 40 by 30, so 1,200. Add the two together, and you have your area. For this one, hopefully you now see, getting the hang of it, you see a big square and a small square on the inside. So the big square is 10 by 10, 100. Small square is 5 by 5, 25. And then we simply subtract the 2. And that would be square yards. Last one, hopefully you see here a triangle and a rectangle. We're going to take the triangle on top and add the rectangle. So the rectangle is 17 by 6, 102. For the top, you have to realize that's 17, because if that's 17, so would this be. And that 11 is the height. So the triangle is 11 times 17, half, because triangles are base times height divided by 2. And then we're going to add these two together, and we got our area. So when you're finding area of compound shapes, you got to notice the two shapes. And then you got to look for certain pieces that might not be labeled. Like for instance, that 3 or that 14, or over here. You have to realize that's 2 and so is that. There's certain times that you can't see certain measurements. So you have to kind of look for them from what's given. And then you just either take 2 shapes and add or subtract, or it could be more than 2 shapes. So good luck with these problems. So now we're going to do compound volumes, because all these shapes are 3-dimensional. So for this one, hopefully you see a hemisphere on top of a cylinder. So for the hemisphere, you have to use the formula for sphere and take half of it, or multiply by a half, or divide by 2, either way. So if the formula just needs a radius, radius was 6. Again, the whole thing is 12, so the radius is 6. Stick the radius in there, crunch it, divide by 2, bam, done. And then the cylinder was 12 by 13, so you just pi r squared is the base, times the height of 13. There's your answer. You add those together, and you have your shape. Add them together, have your shape. There it is. Cubic inches, because volume is cubic. Because it's 3D. Now, for this one, well, you should see a cube right here on top, and inside of it, drilled out, is a cone. So for the cube, let's start with that. The cube is 6 by 6 on the bottom and 6 high. So the base area is 36 times 6 is 216. Now for the cone, you take the base area, which is a circle, times the height, which is, if you look carefully, if this is 6 deep, it looks like it goes all the way to the bottom. So we're going to call that 6 deep. And then the radius is 2, because the diameter is 4, so the radius is 2. So you take pi r squared, which is the base circle, times the height, 6, but you divide by 3, because all cones, you take the third of what would possibly be a cylinder around it. But anyways, cones always have a divide by 3, so do pyramids. And then you take those two and you subtract them. This is important. This one you're actually subtracting because you're cutting it out. For this one, you hopefully see a cone over a cylinder. So a cone over a cylinder. Now, 5 is the radius of the cone, and 13 is the height of the cone. So pi r squared, base circle, times the height, divide by 3. That's how you find a cone again. And then this cylinder is pi r squared, there it is, pi r squared again, times the height of 2, and then you're going to add these because you're just combining them. So let's talk about this house-looking thing. The bottom here, this box, the base is 4 by 4, so that would be 16, times the height is 4. This is a rectangular prism, or a square prism, sorry. And then the second one, this is a pyramid, so the base again is 4 by 4, 16, times the height of 6, but you divide by 3, because all pyramids you divide by 3. And then these two pieces you add together, and you get your volume, which is inches cubed. Volume's always cubic, whatever units. This one right here, this is another house, different shape, kind of. Well, this is, what we're going to do, let's take the bottom box. It's 35 by 10, which is the base area, times the height. There we go, is the bottom rectangular prism. And then the top, well, let's look. It's the base is, what's that base? Well, 35. So that's 35 by 20. That's the base area, the front piece. Okay, times 10 deep. All right. Looks like you didn't even need these two measurements. They're just there to throw you off. And then the triangle is always base times height divided by 2. That's the front. 10 deep. All right. For pyramids, sorry, not for pyramids, for prisms, I'm going to find the area of the base and multiply by how deep. All right. Then another way you could have, and then you add the two, this and this, to get the volume. Now, another way you could have done it is just find the area of this whole front by finding this rectangle and that triangle, and then add those together, and then multiply by 10, and call this whole thing one fat prism. Instead of two individual prisms, you could have made one funky-looking prism, 10 deep. Your call. So for this one, you could have done the same thing. I could have found this L and multiply by 6 because it's 6 deep. So I could find the area of the L and multiply 6 deep. But that's not what I did here. It looks like I found the volume of this upper box, which is 5 by 7 times 6 deep. See the 6 deep? So that front's 5 by 7 times 6 deep. Now you wonder where the 5 and 7 come from? Well, let's look. If this is 20 and this is 15, doesn't it have to be 5? If this is 4 and this is 11, doesn't it have to be 7? So again, you have to be careful finding values that aren't always labeled. Just like up here, when you give a diameter, you have to recognize the radius. This one's a little bit trickier. So again, I found the volume of this little box right there. And then this big, long, skinny box, well, 20 times 4, so 20 times 4 is the front. And then multiply by 6, because that's how deep it is. So I take these two volumes right here, boom and boom, and I get 690 cubic centimeters. So look for the different shapes that form it, find the volume of each shape, and add or subtract them depending on what's happening.